Hi fam. It's a beautiful morning over here. It's bright, it's cool, and I'll be talking about project management in construction. Project management in construction, what does it entail? It has four core. There are four cores of project management according to me in my own book. Project management has to do with planning, it has to do with coordination, execution, and handing over. And in order for you to have a seamless process of executing the project and handing over, you need to take your time to plan the project properly. It is very important. So when you plan the project properly, coordination becomes very effortless and execution becomes very seamless too. That's the essence of planning. It pays to take a lot of time to actually plan a project before executing the project, because this will enable you to save costs. It costs a lot to build, it costs a lot to create, and it also costs a lot to destroy. Nobody is going to destroy for free. For instance, if a building is supposed to be demolished, it will cost a lot to demolish the building, as well as it will cost a lot to erect the building. So in order to avoid spending double, you need to plan a project before the execution stage. You need to plan properly with all stakeholders, and I'm talking majorly about construction. In construction, there are different stakeholders. You have the engineers, the architects, the QS. You have the quantity surveyor, the QS, the architect, the electrical engineer, mechanical engineer, the civil engineer as well. Amidst every other person involved who will be involved in the project. I'm only talking about the core people, the engineers, the architects, and of course, the quantity surveyor. Now, what's the essence of coordination? You see, when it comes to building, there are certain things that must be understood, and that's why, as an engineer, if you must be a project manager, you must be flexible enough to understand the importance of every other stakeholder. You should understand the importance of every other stakeholder, and that will prompt you to coordinate with them when necessary. You see, the structural engineers, they deal with beams and columns, their rods and all of that, and they will not want anything that would interfere with their columns and their beams, because they believe that that has to do with the strength of the building. That's what is carrying the weight of the building, and when you interfere with that, it can actually, create a form of hazard that could lead to loss of life in the near future, if not within the construction period. So it is important to know how to coordinate with them, such that when you're about to do your slab work as an electrical engineer, when you're about to run your pipes, you know how to coordinate with them, such that there are voids that they would not want to, they will not want anything to touch. There are places, I don't know how I can explain it better in civil terms, but as an electrical engineer, it's important to coordinate with them when laying your pipes in the rods, in the iron rods, prior to casting of the slab. Whereas it's also important to coordinate with the mechanical engineer as an electrical engineer, to know that, okay, this is the route of my cables, and okay, I probably what is on the design is unachievable on site, and you are thinking of, oh, I need to reroute my cables or my cable tray through this path, and it happens that you need to find out, you need to confirm with the mechanical engineer, with every other stakeholder, that this is what you want to do, so that every other person can align properly. If the plumber if the mechanical engineer who is in charge of supervising the plumber has pipes passing through that route, then it's for him to now coordinate, for you to coordinate with him or her, to understand that, oh, in order to achieve this thing, of course my cable trays must be routed in one way or the other, then it shouldn't affect any other thing. How best do we do this? So that's the essence of coordination, because whatever will be achieved on site has to be something that every other stakeholder is satisfied with and is acceptable to them. It has to be a pattern that is acceptable to them, such that it doesn't affect them. And they wouldn't do things that will also affect your work as well. So this is the importance of coordination for a seamless workflow. And this is why technical meetings happen on site. That's where different complaints, different challenges, different difficulties are being treated. And there and then, with other stakeholders, you're able to trash out a lot of things and find solutions to it. Because it's a different thing to design, it's a different thing to actually install. Making that design a reality takes a lot, as much as it takes a lot to design too. Project management has to do with coordination as well. You need to coordinate properly with every other person on site. You need to coordinate. Same as an architect. Later on, if you decide that whatever you designed in your layout is not visible on site, you cannot achieve it on site, and you need to change some things. And because of that, the position of a door has to change, or the way a door is swinging has to change. Of course, you need to inform every other person involved in the project, including the electrical engineer, because the electrical engineer can definitely not have a switch behind the door. So if the initial design is showing that there is a switch at that same position where the door is swinging to cover, then it is for the electrical engineer to now re-strategize and find a new position for the switch, if unavoidably the door has to swing to that part. So that is why it is very, very crucial, sacrosanct, important for coordination to happen on site. Everybody cannot be working independently. You need to work as a team. Electrical engineer must coordinate with the mechanical engineer. Mechanical engineer must coordinate with the structural engineer. Same thing, every other person. Everybody must coordinate properly on site in order to have a seamless workflow. And this is also a core part of project management. And this will enable the execution process to be as effortless and seamless, as easy as possible, till the point where the project will be handed over. So this is the bit I just have to say this period, and it's just to admonish and advise clients to sit properly with every stakeholder who will be involved in a project before taking off on that project. You need to sit with the architect, the electrical engineer, mechanical engineer, the QS, everybody. You shouldn't cut corners. It's better to have your planning done properly in order to avoid extra costs or hazard that would likely lead to loss of lives and property in future. So it is very important that as a developer, as an investor, as a client, please take the planning stage very seriously. And I would like to encourage my fellow engineers to always speak out and say the facts. State the facts. Let the clients know. Some clients are not aware. Let them know how important it is to actually plan well before taking off on a project. Advise them as best as possible that you can, in order to avoid setting unforeseen circumstances that could be brutal in future. So that's what I have to say this beautiful morning. See you again next time.